Hello friends, in today's question, a smooth semicircular wire track of radius r is fixed in a vertical plane. One end of massless spring of natural length 3r by 4 is attached to the lowest point O of the wire track. A small ring of mass m, which can slide on the track, is attached to the other end of the spring. The ring is held stationary at point P such that spring makes an angle 60 degree with the vertical. The spring constant K is mg by r. Consider the instant when the ring is making angle of 60 degree with the vertical. The spring is released. Draw the free body diagrams of the ring and determine the tangential acceleration of the ring and the normal reaction. So this is a semicircular wire. This is mass m at point P, and it is making angle of 60 degree with the vertical. So we are first of all drawing its free body diagram, okay, and then we are going to find out its tangential acceleration as well as the normal reaction. So for the free body diagram, there will be mg in the downward direction, and this mg will be having two components. This will be our 60 degree, and so we are going to get this as mg sine of 60, and this we will be getting as mg cos of 60, and there will be normal along this line and we say that there is a spring force kx which will be acting along this, and these kx can be also divided into two components. One component will be along this part and another one will be in this along this axis, and this angle will be 30 degree. So we get this as mg, sorry, not mg but kx cos of 30, and this we get as kx sine of 30, and this will be the tangential part of the, along which there will be acceleration a tangential. So this is the free body diagram for the part A, and next we are going to find out the tangential acceleration and the normal reaction. Okay, so we can say acceleration along the tangent T is 80. Therefore, we can say that mass into acceleration AT, MAT will be equal to mg sine 60 plus kx cos of 30. Mg sine of 60 plus kx cos of 30. And let's find out what will be the, you can say, the extension x. Okay. So the natural length is given as 3r by 4, and the maximum extension which a spring can have is r, because r is the radius and it has to be in contact with the semicircle. You can say the maximum, let us call this equation 1, the natural length of spring is 3I by 4, and we can say the maximum length to which the spring can be stretched is equal to R. Therefore, the extension in the spring, which is equal to X, will be equal to R minus 3IR by 4. So this gives us X is equal to R by 4. Now we are going to use this as well as other values in equation 1. Okay. So we can say from equation 1 we get m into 80 is equal to m g, and we have sine 60, that is root 3 by 2. Sine 60 root 3 by 2 plus constant k is given as mg by r, and x we found out is r by 4, and being multiplied by cos of 30. Cos of 30 is root 3 by 2. So m cancels out throughout, and we can say the tangential acceleration is equal to, this will be taking r also cancels out, so we are left with root 3 by 2 and g, so this will be coming as g root 3 by 2, and taking common this will be 1 plus 1 by 4, so we get this as, this will be 5 and 8, so we can say that our tangential acceleration 80 will be equal to 5 root 3 g divided by 8. So this is the tangential acceleration. Tangential acceleration in the second part we are going to find out the normal reaction. Okay, so along the normal we can say that along the radial direction you can see that n plus kx sine of 30 is equal to mg cos of 60, and the, you can say, the radial acceleration. Okay, So we can say this as n plus kx sine of 30 minus mg cos of 60 is equal to mass into acceleration in the radial AR, okay, along the radial direction with AR as radial acceleration. But the radial acceleration will be equal to 0, okay, because it is not moving along the radial direction. Okay, but AR is equal to 0. Therefore, we can say normal substitute value of k is mg upon r. We know x is r by 4, and we have sine of 30, that is 1 by 2. This is mg, and we have cos of 60, that is also 1 by 2, is equal to 0. So this r goes with r, so we get n is equal to mg by 8 plus mg by 2. So you get minus mg by 8 plus mg by 2. So this will be coming at taking 8 as LCM. So this will be 4 mg minus mg. So normal reaction n will be equal to 3 mg by 8. This is the normal reaction. This is the normal reaction. So this completes the question. Thank you.